Welcome to the Meltzone episode from Monday, December 16th, 2019. This is episode 27, and I'm Tom.
And I'm Stefan. And, well, I talk a little bit about pre-processing algorithms that I developed for creating gradient infill for 3D prints. Tom is talking about post-processing of 3D printed parts using SLA resin. On the news, Marlin 2.0 is finally out, and we just, talk a little bit about what that means. And E3D's new direct extruder, formerly known as the E3D Hermes, is now known as the E3D Chimera. So hard, I always get it wrong. And we just talk a tiny bit about the background and just, about the extruder itself.
Yeah, and topic of the week. Prusa requires you to break your mainboard if you want to flash custom firmware to it. What does that actually mean, and is that actually worth talking about? Well, we talk about it anyways because it did stir up some comments in the community, and obviously where there's smoke, there is fire. Moving on to questions. Igus's tribological 3D printer filaments. Have we used them, and what would we use them for? And what have we used them for? Eric Sederberg is making a lot of corrections and has given some good input on the entire metal printing subject we talked about last time, so we go through those. And then to round everything out, we talk about some more RC flying and some more lightweight printing, including a shout out from Project Eric. Shout out to you as well. Stefan, we're lens buddies now.
Yeah, we're lens buddies.
People love us talking about the meta YouTube filmmaking stuff.
I finally invested, coincidentally, at the end of the year in one of the new lenses. Well, actually, a friend asked me a couple of weeks ago if I'd be cool taking some pictures at his wedding. And even though the GH5 is a really good camera for filming due to the small sensor, it's not the best in low light conditions.
Yeah.
So I thought, it's Black Friday. The lens is a little bit cheaper. Why not invest in something which might last for the next couple of years, I hope. So I also bought the 10-25 f1.7 Panasonic lens.
I'm kind of envious because you got it for a much better deal than I did, because I thought these Panasonic lenses, they don't drop in price for half a year, and then they're like $50 off or something. Yeah. You got it for way cheaper, and you got a cashback too.
Yeah, in the end it was still $1,500, but you paid $2,000.
I paid the full $2,000 retail. Yeah. How are you liking it so far? Is it your YouTube go-to lens already?
Well, to be honest, my YouTube go-to lens is my 30mm macro lens because I really like to get close into stuff. But it will be the lens on my GH5 where I also film as well. And the nice thing with the big aperture is that it's just really cool to get a lot of really nice bokeh in the background.
Yeah, looks pro, and you don't need much lighting anyway.
Either. We'll see.
All right, so I think that sums up the meta stuff. Yeah. Let's head into projects.
Yeah.
And you're first.
Yeah, so I have been working for a couple of weeks on a project that just popped into my head one morning when I drove to work. So I've been working a lot on Extrusion Multiplier and just trying to figure out how wide and how small you can extrude with a normal 0.4mm nozzle on 3D printers. And I figured out that you can go more or less all the way from a 0.2mm line to all the way to like a 1.2 or even a wider line, which might be good for lay adhesion. It might be good for... You got a fly there.
Yeah, you seen that too. God.
Which is kind of nice to print faster, print a little bit stronger. But the thing that came up in my head, why not use this like dynamic of the nozzle and the extrusion system to get a gradient infill in your part. And I have a part right here, just like this clover leaf. How do you say?
Clover leaf.
Clover leaf, where you can see that the area around the perimeter is way denser than the center of the part.
So that is just extrusion width. It's not actual varying the infill pattern like, Cura has that built in with the cubic, whatever it's called, where it has a shell where it's very high density and then the inside is just a larger chunks. But that you're having the same pattern, it's just more or less material in the
Exactly, pattern. Because, well, my goal was to use like just a normal slicer, and the only thing that you vary is the amount of material you push through the nozzle at a specific point during your extrusion move. And that doesn't cost additional time. That should make the usage of material more efficient, because the stresses of like a mechanically loaded part are usually the highest on the surface. And you don't need that much strength in the core of a part. And yeah, it kind of worked out. So what I basically did is I just sliced the part. Cura does really nice comments in the G code where it says, okay, now a section of infill starts.
Right.
And then I took the extrusion moves, just scripted a little program in Python, and always checked the distance of the extrusion move to like the nearest perimeter line. And depending on that distance, I kind of scaled up or scaled down the amount of material that goes out of the nozzle. And the first implementation was with gyroid infill. Gyroid infill because the gyroid infill consists out of a lot very short moves. So I could just take each like step from one point to the next and compare that segment to the perimeter.
You don't need to cut up like infill moves, because on the rectangular infill you just showed, it's literally just one line and you can't really vary the extrusion multiplier, I assume you're using?
Exactly, yes.
During that move, yeah.
So the second implementation was that I took this line that goes from one side of the part to the other and chopped it into small segments, just like 1 millimeter long segments. And then I compared the position of this extrusion segment to the nearest perimeter and scaled the extrusion multiplier up and down. And it's working kind of nice. So the results are really beautiful, as you can see right here. Because for those parts, I'm still in the process of figuring out how well it works and which infill pattern is the best and things like that. But so the scaling on those parts is usually 300% extrusion multiplier just right next to the perimeter, and just like 20 or sometimes even 0% in the core of the part.
Yeah, so that means you're doing like an infill density in the slicer of around 30% max, I guess, because you're doing times 3, so it wouldn't, you wouldn't want to over extrude or extrude more than 100%. Yeah. So that's really interesting, because I've thought about how would you do something like that. I know people who really need that sort of an approach. But right now it's either use the Cura built-in, which just works with that one pattern, or you do like modifier meshes inside your mesh, but you have to like manually generate those either in Fusion or in Blender and shrink down your original part, create extra geometry, and then use that as. It's just a really messy process, and what you're doing is literally just a post-processing step.
And now the thing I'm actually hoping for is this method is totally simple, and each slicer has exactly that information. I'm like reverse engineering myself. So what I would actually hope for the future is just to have a checkbox in the slicer which says gradient infill.
Or just an infill pattern that does that.
Exactly. With the additional parameters of thickness and maximum and minimum extrusion. And I think this, even though it might not be applicable for every part, but it could just bring like slicing software another small step forward.
Yeah, because it's material saving without really deep. Well, theoretically, basically, it should always improve a part. It should never make a part weaker if you're using the same amount of material. It's just distributed more intelligently.
Exactly. Yes.
Now, the question I have is, how does it work along the z-axis? Because you're just showing open parts, so you can see it. But also, I think if you're working on one layer, you're not really capping it off to the top.
So at the moment, it's not working on the z-axis. It could be implemented basically, but this is something I would hope that the slicer manufacturers do, because they have the information. How far am I away from the next wall in 3 dimensions and not in 2 dimensions?
I guess if you're already extracting that information from a 2D layer, you could also extract it from like the next layers up and down, and kind of work your way back and rebuild a 3D model from the G code, which seems unnecessarily complicated.
Well, the thing is, I'm planning to do a video on that either at the end of this year or at the beginning of next year, and all the horrible Python code that I wrote will be fully open source, and there are probably some really nice and skilled programmers out there
for sure
who can improve on what I did and what my idea behind that was. For me, it's just a proof of concept. I want to show that it's possible, and then hand it over to the guys that are skilled.
Yeah, I mean, the most important thing is that you actually made it. You made it work. Nobody else did that, not that we know of, but
this was actually one of the things I thought, okay, I at least have to put a couple of pictures out on Twitter and Instagram, just that nobody else can patent it. I don't know. So
software patents. I don't know if they're actually a thing, but
well, they are a thing. There are Stratasys has a ton of patents on different extrusion moves and stuff like that, which we can't use. There are some moves for like hiding the seam on
tucking.
Stuff like that.
But just because they have received a patent doesn't mean that it's also defendable, which is, I mean, we could get into that entire patent system discussion, but I think that would exceed the capacity of this episode.
Yeah, definitely. No, as I said, I want to bring it out, and like the second stage of that, what I'm really aiming for is take topology optimization data, and topology optimization data is just it's really giving you a gradient at which location do you want what amount of material. So the thing that you're usually seeing at the end of a topology optimization is just that the model that you see is capped at a specific density, but still
in Fusion you have a slider where you can set that cap.
So I actually want to export that data and then map it on my part. And without any like modifier meshes and stuff like that, you can really simply do like gradient infill and really optimal infill at the locations where you need it. It's still not oriented in like the direction where your load goes, but
it's still a linear process.
Yeah, if you apply that properly, you can get 100% infill in the areas where you need it. And this is, it's still beneficial.
Yeah. There you go. And that, I mean, having that topology optimization, that data available really saves you from, well, I guess also from having to detect perimeters and all that.
Yeah,
right.
Because you only take that data. It's really cool. So
how have you found programming the entire thing in Python? Because checking for the nearest perimeter sounds like either something that's horribly overcomplicated to program yourself. Or is there a library for that? Because Python is just import this and import that, right?
I basically never worked in Python before, and I had the idea in the morning. I came back home from work like at 4 o'clock in the afternoon, and I did like a 4-hour session of learning Python and doing like the first prototype of the software. And it's kind of simple. It's a G-code parser, so I take the XYZ and E things out of the steps and then do just some simple mathematics to figure out the positions. Python is really easy. If you have ever programmed in any other programming language, it's so, well, it's different, but it's kind of nice because you don't need to fiddle around with data types and stuff like that. Everything is just a variable.
Yeah. But with programming, it's the same as with CAD or video editing or whatever. If you know like one approach, you just get the basic idea of how things mesh together, and then it's just
Yeah.
the actual craft of using that program.
Yeah, so
Yeah.
I did
Nice.
well, I did some work on G code, and you did some work on like the finished part.
Oh god, you're making me look bad here. Like you're doing all this intricate work, and I just smeared some resin on some parts. Okay. So yeah, simpler stuff. So what I tried, what's it called? XT60 is the RC battery connector. XTC30 is the 2-part finishing resin I think it's XTC30 that he put on your parts, and I thought, well, we already have resin, and this stuff is literally just Prusa SLA resin, thinned down a bit. And I did a few tests. Like there's a lot of detail here that gets capped off. Like you can see between probably nobody can see because it's too small. But between these branches, there's a little hole that gets capped off. I did a bunch of experiments on seeing what would give me the glossiest, smoothest surface, versus also retaining details still, because I think those two are kind of interlinked. I tried or experimented with heating up the resin with a hot air reflow, which just a temperature controllable heat gun basically. With thinning it down with IPA, different brushing and dripping and dipping techniques. And yeah, I think I found something that actually works really well. This thing looks like it's, well, almost. You can still see some imperfections in the print, but this thing looks really good. Like I'm seeing it because I've got the light here. This is very nice and glossy. You hit this maybe with a bit of sandpaper, and it's just perfect. So yeah, these are the shelf brackets that I did with topology optimization, scaled down to 30%, and I also did this guy. So this stuff here is Prusa resin, which does harden well. This is the 1-hour resin that I've never gotten to print because it just doesn't cure through all the way through. And I think on camera, if you're watching on YouTube, maybe I'll scoot over so you can actually see it in frame. This thing looks fantastic. It's just, especially with an alien egg like this, just makes a lot of sense to have it like all sticky and slimy, and it's physically actually still sticky.
But what I can see on the parts is that you still retain like this yellowish hue on the parts.
These were yellow resins.
Okay.
So the Prusa resin is actually the Prusa orange one. So this obviously has an orange tint to it, and this is also the yellow 1-hour resin, though I think most of the dye in here is actually settled out, and I just used like the resin part of it. Though what you can see, maybe I'll show you here down here, and I'll show you guys on camera too. I did use a 50-watt UV LED, just a cob LED with a built-in driver. And if you actually move that too close to the part at full blast, the resin just gives off a small puff of smoke, cures instantly. I mean, it's an exothermic reaction, right? It's just, I guess it cooks itself, it overheats, and in those spots it also separates from the part.
Okay.
But because it's a relatively thick shell, that doesn't matter. But I realized after the first coat, like maybe I should go a bit slower with doing this. But yeah, this is, I'm surprised that nobody else has done this, because this is a really nice and fast way to finish parts.
And it has become quite cheap compared to other resins, probably.
How much is XTC30? Probably isn't any. Well, it's all resin. It's all like in the same ballpark.
You pay $20 for 200 grams.
Okay, so that is more expensive than for example Elegoo resin.
Yeah, so $100 per kilo.
Okay, so SLA resin is around $40 or $50 per kilo, and it's a lot faster to work with because. And I think also a lot easier because you don't have a 2-part mix that you have to mix up, and then it starts curing and you're rushing to get it on. You can work with this stuff as long as you want. And once you're happy with the result, you just pop it in some UV light. I did it with the CW1, the Prusa curing station. and it's done within minutes, and you can put the next coat on. So really happy with the results. This is a lot cleaner than that, than the egg, because you have a container where you catch everything. This obviously, if you actually brush it on with a paintbrush, does work, but you have to reach in there, and it is kind of messy. But I guess, but I guess so is every other finishing process.
Yeah, it looks really interesting. It just gives the part a really nice and shiny finish. And if you would have used for this part either a really black or a transparent resin, it would just look like an SLA printed part. The question is,
it would look better though, because there are no layers on SLA. You can still see layers if it's on an angle. Yeah. What's the question?
Why don't you print those parts then not directly out of resin? It's like the devil's advocate question.
Yeah. Okay. So I've got these parts printing in resin right now. These small shelf brackets, so that I have a comparison. Obviously, that's what comes to mind. If you have an SLA printer, then do that. However, let's get the other glove. You're limited in size, and you can't really post-process. Well, you're limited in size. You're limited in size with SLA, but not with FDM. You're typically printing much larger parts, and you can also assemble parts and then finish them. So, size-wise, really, there's no real limit to this. And I think the finish from covering it with resin and coating it with resin is maybe less detailed, but definitely smoother than what an SLA print is, because SLA prints are always matte. And again, you can still see the layers if you don't add any more filler or primer or anything on top. I still want to paint these things with a really shiny paint, though.
No, they look really, really nice.
This thing looks absolutely disgusting, which it should, which is perfect.
Exactly what you're aiming for.
I'll plant some aloe vera in here, so I think that fits.
And it's probably, even though you're using resin, less messy than an SLA print, because you don't have to clean the parts in IPA, and all the resin that is kind of now in your small box below the bracket, shelf bracket, it just cures and then hardened. You pop it out.
Yeah, so I think I can do that right now. Yeah. There you go.
Yeah.
So this actually comes loose from the IKEA box, because the IKEA box is PP.
Yeah.
And nothing really sticks to that. Yeah. So I don't think this is all fully cured, but I don't want to dig through this. But it does come out, and you're rarely dealing with raw resin. It's also a lot cleaner than spraying it with filler primer or something.
Yeah, I have been working with, I think it was polyester something. It had a horrible smell. It was also two-part polyester thing that you could put in your airbrush. Also, really nice. I don't know if it was polyester, but something like that.
But just the two-part resin in a spray tool. I mean, usually paints are two components, but wow, you gotta clean that stuff out really fast.
Definitely. It also gives a really nice finish on the parts, but it smells so horrible. So horrible.
Yeah. Then it was probably polyester resin, because that stuff does smell really bad.
Cool. So
that was my experimentation and next video topic. Probably the video is going to be out sometime around when the podcast is out.
Cool. Looking forward to that.
You know what else is out?
Tell me.
Marlin 2.0.
Yeah.
Is out of beta. So Marlin 2.0 has been available as a beta version for over a year, much longer than a year. And there's now the 2.0.0 version of Marlin available. So officially ready for production. Manufacturers have been using it for a while already. The Raptor runs with Marlin 2 beta, which is a bold move to run a machine you're shipping with an unfinished firmware, but they do what they got to do. But now it is officially, out.
Yeah, I'm really looking forward to it. It has some really nice features that might be interesting for future printers. Be it only just like using 32-bit boards, being faster, being able to attach like color screens directly to the boards and stuff like that.
Yeah.
Also, things like some features like what is it? The acceleration just one derivative more.
Proper jerk, I guess.
Proper jerk settings.
We've been calling it jerk for a while, but jerk technically is not what the old Marlin has been doing.
Yeah.
So I think that's called junction deviation or something.
Junction deviation.
Yeah. But I mean, obviously, the biggest thing with the Marlin 2.0 is that it runs on all boards. That's literally what the Marlin T-shirt says. For all the boards, it runs on both 32-bit and on 8-bit.
Mm-hmm.
So you can still use your old Mega whatever, maybe not the 644p, but the more modern ones or the bigger chips. You can still upgrade your old printer to Marlin 2.0.
Okay.
Because that's the biggest thing moving forward from now is that Marlin 1 was always made for the 32-bit board, so they would directly interface with the hardware features that the Mega chip offered, so you couldn't really port it to another platform. But now, instead of directly interfacing with those features, there's a hardware abstraction layer. So instead of saying write to that register whatever bit series bit whatever you want, that so that it pulls that one pin high, instead the code actually now says, oh, I want to set pin this to high, and then the hardware abstraction layer does that. And you can just take that top functional layer and put it on that board, which is going to make development, from what I understand, a lot more efficient, a lot quicker, and a lot more universal. So I'm looking forward to what's coming now for Marlin 2.0.
Mm-hmm. And you have already been playing around with compiling your own Marlin. I think I've read on Twitter, because it's different. You can't use the Arduino IDE anymore.
I think you can somehow still use Arduino. But the official, what I used, and I think what's officially recommended, is Visual Studio Code.
Okay.
With what is it? PIO, Platformio. Yeah.
Okay.
So that is basically so Visual Studio Code is basically your code editor, and then Platformio allows you to build for all those different targets. So it allows you to build for the 8-bit board, for the 32-bit, for this platform, yada yada yada. So that takes care of the interfacing to the actual I don't understand exactly how it works, but it allows you to work on those platforms.
Okay.
It's different. I think once it's set up, it's a bit smoother than Arduino, because it's just much more powerful than the simple Arduino editor.
Yeah.
And yeah, it's different. I think I need to do a tutorial on how to set that up. But it does definitely work very well.
Cool. Is Visual Studio Code free, like free of charge? I gotta say that.
It's free as in beer, yes.
Yeah. Okay, because so far I think I've just known Visual Studio from like the professional environment, where it is not a really cheap software, but yeah, that's really nice.
Yeah. It's Visual Studio Code, so I guess it's like a light version of that. I don't know.
But still you have all of the syntax highlighting and stuff like that.
Obviously.
Oh. The things that were missing in Arduino IDE for forever.
Yeah, I was gonna say, all the things you wish Arduino had, Visual Studio Code does have.
Cool.
I think it's still very usable. I don't know what the Marlin team actually develops in.
Okay.
Because at the core, I think Platformio is made to, be cross-platform, not just for what platforms you can build for, but also where it runs. And yeah, they just happen to have a plugin for Visual Studio Code that makes it kind of a smooth process.
Cool. Yeah, really looking forward to it. I still need to upgrade my Sapphire Pro, which is behind me, to Marlin 2.0, because for fast printing with that machine, I really need to use Linear Advance, because otherwise it's just the print results are not really nice.
Yeah.
So
too shaky. Yeah.
not too shaky, but the extrusion system is too. Well, what's the difference between what's the opposite of like slowly reacting because it's about an extruder?
Yeah.
Träge.
Yeah, exactly.
Damn you, English.
People know what we're talking about.
Yeah.
Speaking of the extrusion system on that printer, I'm gonna go wash my hands real quick because I've got resin on them.
Okay,
Be right back.
No worries.
I'll add a marker in the audio track so I can find it. By the way, did we get any input on chapter mark tools?
I
didn't see anything there.
haven't noticed.
I think I looked through nothing about them. So please, guys, if you know a tool that lets us do chapter marks, let us know. Okay, E3D Hermes. How is it spelled? Hemera.
Is it Hermes?
There we go. Not a Hermes.
Well, I don't.
What a mess with that name.
I think it's not Ja, stimmt, es Hermera. I always thought it was Hermera. Okay, perfect. So the thing was, lots of like guys from the community had one of the pre-production units of the E3D Hermes.
Formerly known as Hermes, yes.
Hermes. And just like the night before they released it, we all got an email telling us, okay, sorry guys, I think we need to rename the extruder due to some legal problems we ran into.
Yeah, I don't think we can. I think we both know which company it is specifically, but I don't think we're supposed to tell you guys which company that has interest in the Hermes brand name was actually threatening them.
Yeah.
Or let's say, kindly hinting at the fact that they own a trademark.
Yeah.
But yeah, holy crap, they did pull it off.
Yeah, just in one night renamed everything and stuff like that. The interesting thing was when I later checked my still Hermes extruder was that I think they tried to trademark the name E3D Hermes or something like that. And probably this was one of the reasons why it popped up in some system. I don't know, but I could imagine that this was the case because there is like this R thing or something like that on the old Hermes.
I need to check that.
Yeah,
but I think they already own trademarks on the products that have a name.
Yeah,
I don't think they can trademark E3D V6, but mostly that is to stop like Amazon and eBay selling fakes and calling it E3D Hemera or E3D V6. Because really, on a how else could they defend the genuine E3D brand?
Yeah,
they're okay with clones being sold as E3D compatible or whatever, I guess, but you shouldn't. Yeah, and at that point, it's not even. I mean, if somebody's selling it as an E3D Hemera and it's actually a knockoff, it's not a clone. It's a knockoff. It's a fake.
Yeah.
And the only way to defend that, I think, for them is to have a trademark on it.
Yeah.
So yeah, I think that's the background of that. But I guess some company was first and claimed the entire Hermes brand for themselves, which is interesting because there already are multiple companies using the Hermes branding.
Seriously, okay. I wasn't aware of that. I just know like one company which is also called similarly.
Yeah, I mean, the two companies that I can think of and that they've been brought up on Twitter is the delivery service.
Yeah.
Which, by the way, that they suck as a delivery service. So that's just my opinion. And the luxury brand. I think the French luxury brand that does, I don't know what.
Okay.
But they're spelled with an apostrophe over the second year. So Hermes or something. I don't know.
You mean an accent?
I don't speak French.
Didn't you learn French at school?
No, I had Latin for
You had
3
Latin.
years.
Yeah, okay. Yeah. Was probably worth your while.
Yeah, definitely. Sure.
Yeah. We'll see. Yeah.
So yeah,
So
that's that. You've had one, right? You liking it? You agree with the reviews that
yeah,
it's gotten?
I really enjoy it. I really enjoy it. The thing is, I think I'm the only one using it in a Bowden configuration. So I can't directly compare your results to mine, but so far it's just nicely engineered. It's quiet. It just eats everything you put at it.
Yeah.
But as I said, I still have some issues with my Sapphire printer, and I need to upgrade firmware and stuff like that before I also do a review or a guide of the Bowden version of the Hermes. But yeah.
People have been complaining about my review that there's not a lot of printing and printed footage in there. But I mean, the thing is, how are you supposed to show something that's just good, that's just reliable? You just show a printer doing its thing and printing and producing good parts. It's it's I could have shown just parts, but it's like, what's the point of that? The really the big thing for me for Hemera is cost. It's just massive cost reduction versus I've got it in the video, versus the Bondtech BMG, versus E3D Titan setups, or just any other extruder setup. It's almost like you're getting the V6 thrown in there for free. You're getting free, not hot end, but hot side. And yeah, I think cost is really the only differentiator at this point, where extruders, if it checks the boxes, it's dual gear, it's geared down 3-to-1, the hot end's good, they all print extremely well. They all print super reliably, the Bondtech stuff as well. And Hemera is right up there. It's really going to have to be price at this point.
Yeah. And because 110 pounds for the whole extrusion system is really, really competitive.
Yeah.
If you're only buying like a set of Bondtech gears, it's $35-$40 or something like that.
Yeah, I did the comparison. The Bondtech set with a V6 is 50% more.
Okay. Yeah.
But I was going off of MetaHacker's pricing, which some people say, you can get these parts for cheaper. Yes, I get that, but
ballpark.
Yeah. But yeah, that's that.
Well, and the extrusion, like the how do you say, like the distance between the feeder gears and the hot end is kind of like the shortest that you can imagine, which makes it so good for flexible filaments and makes it way more responsive, because you like get rid of a lot of flex of the filament.
Yeah, though I think that would lend itself to doing an actual A/B test of going, okay, this is the same extruder gearing, but now I'm using the Bowden version and I'm adding a bit of length to the length where the filament is under compression. And just changing nothing else about the setup and just doing one test here and one test there and seeing how much of a difference that actually makes.
Well, probably not too much in the end, because even with kind of a long Bowden tube, you can get really, really nice prints if you tune your settings in right. But yeah,
it if anything, it makes it less complicated and easier just to get it tuned into perfection.
Yeah.
Because you don't need to compensate for, having long retracts in Bowden systems, for example, or having linear advance on the extruder. You don't need those tricks. You just have, filament in is filament out. Still not perfect, because it's still a molten glob of filament in there, and that's highly non-linear, as everybody who's ever made an extruder and tried to engineer that knows. I've never done that, but I'm told that's how it works. So it's still a really messy system, but at least we can take out as much of the uncertainty as possible.
Yeah. Cool.
Yeah.
So now it's not called Hermes anymore, but Hemera. Oh, hard.
E3D Hemera, formerly known as Hermes, as its full name.
Yeah. All right. So I have been working quite a lot this week, and the last weeks, and there was something popping up on Twitter, I think at Wednesday or Thursday or something like that, which I just followed, well, on the side. So I don't know, maybe you can explain what all the fuzz was about.
Okay. Prusa, obviously, because again, you guys know what we're going to be talking about. So obviously, it's very easy if like 3 or 4 people have a strong opinion on something, they can really inflate a topic. I don't know if that's what happened, but let's just say there's been a discussion going on about Prusa requiring you to break your mainboard to flash custom firmware. So I don't think I've seen that on the early units of the Prusa Mini that they've shown, but on the Prusa Buddy board, I believe it's called, which is the 32-bit board running the Mini. The Mini, by the way, is being shipped now, so people actually have the actual finished Mini. There is now a system in place where you cannot flash your own firmwares because the firmwares, or at least let me back off a step. So the Buddy board runs a real-time operating system, like a Linux system. I don't know what exactly. And then it basically has a container, as far as I understand it, a container for what is a custom version of Marlin that runs inside that operating system somehow. Don't ask me the details. So it's Prusa's operating system that does all the Wi-Fi and the nice color screen, I think, and all that. And then there's a Marlin core that does temperature control and motion and all the 3D printery bits. And I think that's what you can. That and the entire operating system is now signed. So which means you cannot program your own software onto it unless you also have the master signing key that Prusa obviously is keeping on the wraps. That is number one, and that's actually how most commercial manufacturers are doing it that want to keep their products protected. I mean, just think of the Xbox or PlayStations or whatever, where it's basically impossible for you to put your own firmware software on it. Now, what Prusa have still done is they've enabled you to still run your own, I guess, Marlin versions on that board, and I think also it enables DFU, so that's the deeper flashing interface for the real-time operating system. They allow you to still replace all that without signing it, but you have to break out a tab from the board. So you have to physically crack out a bit of the PCB of the Buddy board to allow you to flash and run your own software on it. Now, all that does is, it's a bit of a workaround for Prusa. So first of all, the processor now lets you access those programming features without requiring the Prusa signature. But on the other hand, Prusa now have a physical way to trace that you have perhaps at some point flashed firmware to that board. What I think it actually is, then okay, the result of that you've broken out that tab is that Prusa will decline warranty on the electronics if you've broken out that tab, which means you have potentially flashed your own firmware on it. You may have burned up some parts of the board, which was outside of Prusa's control. What I think, the reason why I think Prusa are actually requiring you to, I guess, break the board is that as far as warranty laws go, you can't actually decline people warranty because they have run custom firmware on a product. For example, on phones, I think it's the way if you run formerly CyanogenMod on your phone instead of the stock software, the manufacturer cannot decline warranty if, I don't know, the speaker fails. Mm-hmm. Which may have been caused by the software, but they still can't really decline it. It's a bit of an odd situation. So it's the same with 3D printer firmwares. I can think of code right now that will sneakily burn out your board, your heated bed MOSFET after 1,000 hours. It will work fine for 1,000 hours, and then suddenly it'll set fire to itself. You can do that with a firmware. And basically, by having that tab broken out, Prusa is saying, okay, if for some reason your custom firmware burns down, the printer burns down your house, does whatever, you can still, because it's copper within that PCB and that's not going to melt typically, you can still see, okay, it was missing that bit. So it's a way for Prusa to decline warranty because you've broken, quote unquote, your board. But it's also for them to get out of liability if you do mess with the printer and it starts acting up and fails in a horrible way. Yeah, so that's the what they're doing. Now, people are picking it up as Prusa are now restricting what we can do with the printer. Because that they're requiring you to sign the stuff, or they're requiring the firmware to be signed by themselves. And for some reason, open source is being tied into that and saying, oh, that's not in the open source spirit, which I can see, yeah, but you can still break out that tab and turn it into a developer edition or something, I don't know. And there also is, which I think Prusa have failed to communicate particularly well, there's also a developer program. So that officially sanctioned or officially approved firmware mods can be run on the stock Mini without having to break that tab out.
Okay.
So still covered under warranty, still fully supported. Well, I guess not supported, but still covered under warranty by Prusa. Tab stays in place, but they approve firmwares or mods to the firmware that people can then flash.
Okay. I wasn't aware of that. First question.
Yes.
The software, the firmware itself is still open source?
Yes.
Okay. So
minus the signing key.
Okay. So kind of the only thing that you got to do you put like a new hot end or a new extruder, which is like not compatible to the current firmware, is that you need to break out the tab and then you can flash your own firmware. But so those things are not then covered under warranty. What I can understand, because having that many printers out in the wild and being a company that does support on their printers, you kind of need to have a way in order to distinguish printers that are not working anymore because somebody fiddled around with them, and printers that are still stock and you kind of messed something up and that's the reason why they not work anymore. And I think this is kind of a legitimate way of doing that. In my opinion, it doesn't really take away something from the user, and I totally understand that Prusa did that because firmware and electronics modification can screw up things, and they, on the one hand, don't want to support that because that's additional effort for them, what costs them money, and the Prusa Mini is already built to a price. And on the other hand, we had the incident where one of the Prusa printers started burning because something wasn't like properly rigged up there, and I think this has already caused them to be cautious in that direction, that if something like that happens again, they have an easy way to directly say, okay, this printer was modified, it's not stock anymore, so we are not liable anymore.
Yeah, at least so if it's a hardware mod, like what happened with the Burning Mark III, that's relatively easy to see. Well, after it's burned down to a pile of ash, maybe not anymore, but it's relatively easy to see if you go to a printer or you get sent a picture of it that, hey, this is a different hot end, there's something been modded here or whatever. That's hardware. That's easy to trace back. But if it's just firmware, there's really no way to like detect what version of firmware it was running when something X went down and maybe the chip burns or something, or you could even reflash it to the stock firmware if it's still working that much. So really, there's no way to trace what exactly has happened. Yeah, and also like there are two things that I can. Well, I guess three things that I can see that play together here. So the first one is intentionally malicious firmware. I see firmwares being traded around for ANET printers for whatever that somebody compiles, and I have also created an ANET A8 firmware with a hex file that somebody can flash. Nobody can check what I did there. Like that example of 1,000 hours into using it, it'll just ignite itself, you have almost, as a user, you have zero ways of checking for that. And even if it's firmware source, and I mean, if in the end it's still Prusa's machine, or the machine. Prusa doesn't own the machine, but Prusa is liable for the machines, right? So that's number one: intentionally malicious firmware. The other one is just firmware screw ups. Just not having a safety feature in place that ends up burning something down. And the third one is because you can't just flash the Marlin, the motion code, and the control portion of that. You can also flash the operating system is just malware that's because it's the Mini is Wi-Fi connected and all that. It's in your home network. It would probably be trivial to add a backdoor to that real-time operating system that somebody else is able to gain access to your network and to your devices or whatever you've got on your network that way. So it's those three things that are both in the interest of Prusa and in the interest of the users, I think, to a certain extent.
Yeah.
And if you do want to mess with fire, I mean, it's the Here Be Dragons. Is that how it works? Yeah, Here Be Dragons. Sound basically, yeah, break out that tab and you accept that that risk you're taking, which flashing firmware, especially on an internet connected device, always is. And on a device that is, responsible for handling thermals in a way. And yeah, you just say, okay, I'm not going to claim warranty on that board. That's all that's happening.
Yeah, but still, if bearings fail or any other mechanical parts, it's still covered under warranty. So Prusa's not saying,
yeah, absolutely,
there won't be any warranty for the whole machine anymore. It's just the electronics, which is totally understandable.
Yeah.
So,
I mean...
in my opinion, he doesn't really take something away or is against the spirit of like the open source community. He still provides the firmware. He still provides in a simple way to flash your custom firmware. You just, I don't know, it's an additional step, and maybe sometimes it might be even better that users are more aware what they are doing by the step of flashing a firmware which they downloaded somewhere on the internet. So
I still think Prusa could have done better there.
Okay.
First of all, communicated much earlier, because this is now something people are discovering as they receive their minis, expecting something that is as open as the Mark III, which has zero checks.
Yeah.
So they could have announced that and went like, okay, we got the developer program and you can still do everything you want, and the only thing is happening is we're not going to warranty your mods. The other thing I just forgot. No, the other thing is that I know why they've, or I think I know why they have that tab. It's because they cannot decline warranty if it's just a software mod. So they actually require you to what's considered breaking the board. I think that's a pretty brutal way of enabling custom firmware, by literally tearing out a tab of the board. It's like it's got score marks, like it's supposed to be broken out if you want to, but you actually need to damage your board to do that. And I think that kind of sends the wrong message. Yes, it's permanent. Yes, it's whatever. It's the, I guess if it was like just a little ear that he broke off and not like out of the center section of the board, you've probably seen the picture. If it's just a little ear that he break off, like a key or something, maybe that would have been better. And the thing is also, I think it was Samsung with their Knox security system that prevented custom firmware flashes on their S5, S6 phones, where you could still flash custom firmware, but the processor actually burned a trace within itself once you did that. It was that was permanently burnt and permanently open circuit. It was irreversible, but it's invisible to the user. Technically, you can still check for that fuse whether it's burnt or not, but it's not like you're ripping out a piece of your board.
Yeah.
Still, same effect. Maybe a bit harder to check for if you're recovering a chip from a fire, but same effect to decline warranty on modded boards.
Okay. Well, Yeah, I totally understand that, and the way they communicated was probably not the best thing.
I mean, they didn't.
Well, they
didn't
did. Yeah,
communicate it at all. That's the.
I think the guy who started all of the conversation, he had a screenshot out of the manual in that tweet.
Let's open it up.
Yeah, let's open it up.
Louis.
Well, maybe it was. I don't know how long the lead times for those boards were, and if this was something like an afterthought to the incident that happened with one of the Mark IIs or Mark IIIs, or if they have already planned that for a longer amount of time. And if they have already known that for longer, I think it was really bad communication. If it was just like in the last second, yeah, still they could have communicated it better.
They should have, yeah.
But yeah.
I don't remember seeing it on the board that I saw at Earth where the Mini was announced.
Okay.
But I also didn't specifically check for it, so I might have just missed it.
Link, by the way, to the tweet is down in the description.
Yes, very much so.
Well, it is a feature on the board that stands out. So probably if it would have already been there at Earth or it wasn't announced at Murph. At Earth, you probably would have seen it if you have been taking a look at the board. I
don't know. I guess to sum up my thoughts on the entire thing is like, I wish there wasn't a waiver of warranty if you flashed your own firmware.
Yeah,
everybody wishes that. Everybody wants that, and I think that's in the spirit of a open source developer board. Yes, for sure. But Prusa are shipping so many printers right now, and I'm sure they've dealt with customers that have messed up their printers by software mods or something, and then they want Prusa to fix it. And actually, just today, I got an email on, hey, I built this Prusa clone. Can you please help me fix this firmware? And I'm like, it ain't my responsibility. It's your thing. Sorry, I can't offer email support for everyone who builds stuff. I'm sure they could have done warranty for all the custom firmwares and use cases people have with their printers, but it's just going to drive up cost.
Yeah,
it's just everything's a matter of how much money can you spend on this, and I think in the end they decided, okay, if it's insurance for liability that goes up, it's support costs by their employees, by the people that the Prusa employ. It's just going to drive up cost, and it's probably smarter to have a default cost-effective printer, instead of paying for all the screw ups that people could do with their machines. And I'm not saying that every custom firmware is a screw up. There's good community work too. One thing that's been brought up in the Twitter threads is that what if you actually fix a bug that you found in the official Prusa firmware, and you need to be able to develop on the board, you need to be able to flash firmware to that to fix that stuff for Prusa. What then? You still waive warranty.
I don't know. This is probably one of the rare 1 in 10,000 cases. I don't know.
Probably, yeah. Though to be fair, if people have Prusa to fix bugs, Prusa should just send them a new board.
Yeah.
Or send them a developer edition. I guess once, though that's also hard to say, because you'd only get that reward and that payment for waiving warranty once you've actually fixed something. If you're just working on it, if you're just in the process, you don't have anything to show for yourself.
Yeah.
Even though you may be contributing. It's an edge case. I think that's still something that needs to be resolved somehow.
Yeah.
Like just that, or if you need a development board, just have Prusa send them one out with the tab broken out or something like that. I think that's something that could be solved.
Indeed, yeah. Well, we'll see how it will turn out, and I don't know how strict they are on their warranty claims. But yeah, as I said already in the beginning, I totally understand why they did it. So
Yeah, absolutely understand it. I wish it was different.
Yeah.
But it's how things are.
If you want to be a profitable business, and if you want to have, like, if you want to provide proper support, support is expensive. And
I guess one quick anecdote to maybe give some context. What I'm noticing on live streams on YouTube, the streams that I enjoy the most are the ones that have less than 1,000 viewers, where it's literally just the core community, the people that actually enjoy my content. I really enjoy that. Chat is very well behaved, helpful, friendly. But as soon as the stream blows up, like I think the SL1 unboxing kind of went to the edge of that, but also definitely the live build of the Prusa clone. Once YouTube starts recommending that content to more people outside of like the core of the folks who really love your content, it just gets messy. Like, you get trolls, you get idiots, you get explicit word people. You just get such a wide range of people, some that really don't know what you're even doing, some that maybe have a clue but know everything better, some that are just indecent humans. You get those people, and Prusa is in that same spot where they're so popular now, especially with a low-cost printer, that they're not just going to get the people who actually know what they're doing. They're also getting the people who, well, I don't want to discredit any other project at this point, but you also get the people who are kind of just read one or two things on the internet and think they know everything. You also get those people, and they, the bigger your brand is, the more likely people are to actually break things, I think.
Yeah.
Or just do dumb things. So, yeah. Maybe that helps give some content there.
Yeah.
Have we covered the Prusa situation in its entirety?
I guess
as much as we should. Yeah.
Yeah. So
I think it's being made into much more of a deal than it actually is.
Yeah. As I said, we'll see how it will develop, if there are cases where things happen that would not have happened before, and how they handle it.
And it's what other company is doing it better than that?
Yeah.
Or is offering support on yeah. Okay. Questions.
Yeah. Alan Cohen is asking, anyone have experience or thoughts on IGUS tribological 3D printing filament? I'm thinking of giving it a try for some oddball bushings I need. Seems like a material the Meltzone might enjoy.
I actually just remembered I did print with it. Because we obviously go through these questions before we start recording, but I did print with it, and that was for that garden hose roller thing where I had 2 printed bushing inserts. I did print with it, yes.
So,
actually, yeah.
You have already worked with the IGUS, is it Igli Dur or Igli Glide? They have both. So, IGUS, they are like known for their bearing materials, and everything that moves is things that they create. And they also have the material that they use in injection molding, and actually also SLS 3D printing as a filament available. And there are different types of material, and most of them can be printed on just like a standard FDM 3D printer that you also have at home. Yeah. You already played around with it. I printed a bushing for a trapezoidal lead screw a couple of weeks back. Worked quite well. I also just have a sample that I got like 2 years ago at Formnext.
Yeah, everyone has those little packs. Yeah. What is it, 10 meters? No, 5 meters or something. Not a lot of filament. But for bushings, you probably don't need, well, you rarely need all that much material, because if anything, you're just printing the bushing. You're not printing the entire part out of that stuff. For me,
sorry, continue. I can remember that you said in that video that you had issues printing with it, probably also because it was already quite old.
Yeah. It doesn't seem to be the easiest material to print, just in general. Of course, they have a bunch of different grades of filaments: 180, 180, 150, PF, BL, J260, C2. So they've got like almost 10 different filaments, which are all kind of made for different processes. And some are just made to be really easily printable. Some are made to be wear resistant with special material combinations. I'm sure there's one that's a bit easy to print.
Yeah. And it can offer the advantage of a real bearing material. So if you have applications, I think it's definitely worth a try. And well, I didn't really like test it in depth. It was working, but for that application, probably ABS or PLA would have been working as well. But if you have kind of demanding applications, yeah. Go for it. I dried my roll before I used it, and it was working very well. So again, as with other like more technical materials, keep it dry. It makes life way easier.
Yeah, and it's I think Egos are giving you some numbers of lifetime expectancy from just material A, material B, material C. I think they've compared PLA or ABS to their bushing.
Yeah,
bushing or bearing. Bearing is always a rolling bearing, right? Is it?
I don't know.
Whatever. Their printable materials are not quite as good as the actual injection molded IGOS bushings that you can buy, but they're pretty close. They're like 80% of the lifetime of an injection mold. It's something in that ballpark. Because obviously you need to make it printable versus making it injection molding ready. So different requirements for those two different processes, and apparently there's a bit of a step down for the 3D printing materials, but still, it's a lot better than, for example, the PLA bushings that the early Prusa metals used. So a lot better than that.
Yeah. And the interesting thing also is what IGOS is providing. You can upload your step files on their website, and they will print those parts in SLS IGOS bearing material. So
Ooh.
Yeah, that's really cool. And they also have a service where you have like the design customizer that you also have on Thingiverse. On their side, you can design gears and bushings directly in the browser and get it printed in SLS in their bearing material. And
that is nice.
That is really nice and can be handy.
Do you know how much that is roughly? Like reasonable, expensive, crazy expensive?
I think, well, it's not the cheapest, but it's not crazy expensive. So if you just have the application for some special parts, it might be even cheaper to just directly purchase it from them, having it printed out in a higher grade of their bearing materials instead of buying a lower grade material and printing it on your FDM 3D printer.
Yeah. And obviously putting the work in, tuning the material, failing at the print, you're just guaranteed to get a part.
Yeah. So if you're interested, also links in the description.
Cool. Let's move on to Eric Sederberg's thread of comments and input and very helpful stuff that we saw there. Okay. We've not really sorted these. But let's just start with the top one. So the company you were thinking about with the sand plus metal powder is Iro 3D. Are they Italian?
No, they are.
No?
I wouldn't. They are either Northern American or Canadian. I think they're placed somewhere around Seattle or Vancouver. Probably Seattle.
Your browser does not currently recognize any of the video formats available. That's a good Google hit.
Oh, yeah.
Okay, so they're doing that. Next up, for DIY Metal Dd Welding, a friend of mine did that a couple of years back, and it did work reasonably well, but the resolution, of course, was not great. Stockholm Makerspace. Yeah, there's a picture of that. So Dd Welding is what?
Is like having a MIG torch on a robot arm or a 3D printer or something like that on a
Okay.
CNC, just melting wire and creating your rough part with that. But it will mostly require you to machine all of the surfaces.
So it's basically what this old Tony did.
It is what this old Tony did in one of the last aluminum videos. Yeah.
Well, I think it was like 2 or 3 years ago where he printed a very similar part. I don't know if you've got the Instagram open, but just printed a ring onto a flat metal sheet.
Yeah. It is an interesting process. And yeah, depending on the application, you might even be okay with leaving the surface as is. And I think the bridge that was printed that way in the Netherlands, it was looking like that in the end. If you want to use
it, the mating surface and stuff, you do have to either weld on plates or something or machine it down.
Yeah, because exactly.
It's really rough.
One of the parts in the Boeing Dreamliner is also manufactured that way. Norsk Titanium, they are also doing I think they're doing DED welding. And they also produce the rough part in using the same process, but then they machine all of the surface and they end up with a finished part, which is like near net shape 3D printed, and you save yourself the hassle of machining a lot of material away, which is especially expensive in titanium, because not only the raw material is expensive for titanium, but also machining titanium is way harder than aluminum. So something like that makes sense if the materials are hard to work with. There are other companies that use this process for repairing stuff. So
for building onto defective broken parts.
Exactly. So either you just machine away the areas that are corroded or things like that, or you really just chop your part in half and build up parts of the structure again. So there it is a really feasible process, because you might have a component that costs a couple of $100,000, but you have at some location a lot of corrosion or wear just due to the way it's used, and you machine it away, you put new material on there, then finish it up again, and you have a kind of new part.
Yeah, I guess the way that would work without recamming for every single failure mode is you actually machine away to a certain level that you've accounted for at some point. So
exactly.
If you have like one bit, you just always depend, no matter if it's just the top or the entire thing that's broken off, you just machine the entire thing away, and then you have your fixed preset operation that builds onto that nice machine surface.
Yep.
Kind of like what the i3 does for actually fixing body damage with a carbon fiber shell. You just always mill out a set panel, and you have a replacement panel you glue in. Yeah, it's kind of expensive to maintain.
Yeah. All right.
That's
next
nice.
correction also by Eric again. We talked about MIM FDM 3D printing in the last episode, where you print a metal filled filament and then debinder and sinter it. And well, he for once said that the debindering process that is used for debindering the ultrafuse, so taking the polymer away from like the remaining powder particles, is done at 150 degrees Celsius in an oven in a nitrogen and nitric acid atmosphere. So I think
nice.
So probably
you
not.
Don't want to stick your hand in there.
No, probably not something you want to do at home, or you probably even can do at home, because I think this was the question why we discussed that the last time. Yeah. Though there are other materials on the market that are not catalytically debindered, but for example, debindered using a solvent, like for example, Desktop Metal is doing.
Yeah.
Yeah. The other thing that he also said, or where he just said, okay, pay attention. So the binder that is used in the ultrafuse, so the polymer is POM, and if you are printing POM, formaldehyde is, well, released during the process. So don't do that in your living room or stuff like that. So if you're working with that material, make sure that you have a well ventilated area.
Yeah. And apparently, the last thing he's saying here is the main binder is POM and the secondary is PE, polyethylene. That's just left once you've catalytically converted the POM and washed that out. You still have some PE left. And I'm guessing that just gets burned off because PE, I believe, burns off pretty cleanly. That is just burned off during the sintering process then, I'd assume. Because if it's just metal particles, it's not glued together by anything technically. It's not, metal doesn't really want to stick to itself unless you have it sintered, of course. And the PE is just that last bit of remaining material, which makes me wonder, why not have everything just be a PE binder?
Probably because during the burnout process, lots of gases start to form and they might screw up like the structure of your sintered part, because
so you
kind of breaks apart.
So you turn your, basically that 3-step process it is then, you turn your part from a metal powder plus POM plus PE into a metal powder plus PE sponge.
Exactly.
That allows all the gases from the sintering process and the PE burning off then to escape cleanly out of the part as you sinter it, and then you sinter it down and actually turns solid again.
The PE is probably only there to give like the brown part still enough structural integrity that it doesn't directly fall apart. But I wasn't aware of that as well. Interesting. Yeah. Sintering usually takes place at around 80% of the melting temperature of a material, just for the curious.
Yep.
Cool.
Let's move on to a few lightweight questions. So, moving from heavyweight metal to the lightweight expanded polypropylene that I'm gonna butcher that name. Fritzes is asking about. So EPP, expanded polypropylene, is it something commercially available, or that's still a sneak peek behind lab doors? So EPP, the way that I mentioned it, is actually kind of like a styrofoam material, something that's not being, it's not a printable material yet, but instead it's something that is being expanded into molds basically, and that's what that flying wing I showed off last time, or the time before that, is made of. It's again, it's like a styrofoam material but made from PP, which is a bit more durable, a bit tougher. And yes, it is commercially available. The way that they're doing it with a resin basically that is being expanded in that mold, but you can also buy it as sheets and then cut your own wings and forms out of it with a hot wire, for example.
Exactly. Not only airplanes are made out of EPP, I think also if you ever ordered pizza and the pizza delivery guy comes with this styro thing box, I think that's also EPP. Often.
That could be very much true, yeah, because it's a lot tougher than polystyrene.
Yeah.
And should still insulate just as well.
Yep.
And staying with the lightweight topic, Project Air actually commented, "Hey, I'm proud that we're getting some reach with the podcast." So Project Air is working with Tom Stanton a lot, and if you've watched either of their videos, you will know that they're incredibly enjoyable. So Project Air is excited about composite planes with PLA ribs, and then a transparent or traditional covering material. And have you done that? Have Flight Test done that? I think somebody has done something like that before.
So the next question is basically the same. Also asking if you could just print the ribs of an airplane and then cover them with, in Germany it's called
Bügelfolie.
Bügelfolie, but
there's a brand name for that.
The brand name is Aura cover.
Yes.
Aura cover. And Aura cover is
cover?
the foil that you iron onto the part, and Aura stick is the one with, I think, the like sticking backside. Getting back to the question. So a colleague of mine tried that process out, but he had the problem that before actually the foil started sticking on the ribs, his PLA ribs started melting. So I think you kind of need a bit of experience in that process, that you get the temperature just right, that the ribs and the foil sticks together. Maybe PLA is not the perfect material for that application. Maybe it's better to use something like PETG. I don't know. I haven't tried it out myself. This is just the experience at least a colleague of mine had. But there are designs available on Thingiverse where people gave it a try, and it worked out really well. And also he told me that the Aura cover was working even worse. He ordered something from the UK, a special really thin foil that also works really well for like ironing it on wings.
Yeah.
And that's probably a really good application and way more lightweight than printing the whole like wing itself, because the thickness of the material is just it's too big. It doesn't necessarily need to be that thick, so you're wasting quite a lot of material on the fuselage and the wing just because the process is like that.
Yeah, well, what I'm starting to understand about at least model airplanes, at least foam model airplanes, let's be specific there, is that basically you want your airfoil and the main chunk of your part of your plane to be something that is not necessarily rigid, but actually kind of soft and robust. So, for example, with that S800 foam wing, there's most of the stuff is made from EPP foam, but there are two carbon spars running through the main what is, I guess, the fuselage into the wings. And basically those give the entire thing its rigidity and its stiffness. If those weren't in there, you could just fold it in half. But it also means that if you crash, which everyone will do at some point, you have all the foam that can kind of deform without it breaking, and the carbon spars on the inside, they're just kind of protected, and they give both the strength. Ding dong. They give both the strength and the rigidity to your part in the end, but they're being protected. So maybe something like that, where you have, again, carbon fiber spars, I think, are a really great option for that, where it's 8mm or 10mm tubes just running through a lightweight PLA, the expanding PLA, which I guess is also SAW. Do you need to answer that door?
Yeah, I think it's the UPS guy. Just give me 1 second.
Okay, let's pause real quick.
I was waiting for that. I ordered like a ton of stickers for my patrons, and this was like the last batch that just arrived. So now I can send them around.
Good luck packaging those.
Back to the topic.
But anyways, having a combination of like a carbon fiber spar and I guess the lightweight PLA would also be kind of squishy and softer because it is a foam. Having that just as the shape of the airfoil and giving it strength with something else. So you don't need to actually give the wing itself, for example, strength with the printing material. You just make it as lightweight as possible, and then and also they've got very short TPU, which could be very similar in a printed form to EPP form when it comes to how rigid it actually is. And that's a foaming TPU.
Yeah. I think for beginner airplanes, that's definitely the case, that this is a great combination. If you really get into high performance airplanes, this squishiness and like compliance of the part is not something good, because it makes the plane less predictable. So like for really high efficiency planes, you want to have everything as stiff as possible, but you shouldn't crash those.
Yeah, that's the thing. I've actually, I've done a lot of RC, 1/10 scale buggy driving and all that. And I did like the cheapo kits and cheap components for a while. And then I was like, okay, let's get a nice remote. Let's get a nice B4.1 1/10 scale rear-wheel drive buggy. And the thing is just I've actually enjoyed running the cheaper models much more than the expensive stuff, because you're not worried about breaking stuff. I mean, yes, you are, but if you do break something, it's not like, oh, now I gotta order parts for $80 again. Oh, damn it. You can just focus on having fun instead of always repairing. And as long as you're not competing against anything, as long as you're not in races or competitions or stuff, as long as you're just doing it for fun, like, come on, just
Yeah,
again, flight tests are all about building stuff from $10
Foam
bucks
board.
worth of materials, and if it flexes, it flexes. They seem to be having fun, so
yeah,
they're
definitely
doing something right.
Well, it is a great addition to the hobby. As I said, as I started, there was just styrofoam, and my first airplane that I got horribly exploded into 1,000 pieces when I first crashed it.
People are still managing to explode those EPP wings.
Yeah, but
plenty of YouTube videos of those just being completely obliterated, and I've sent mine into the ground pretty hard, and so far it's holding up.
yeah. Yeah, so yeah, I'm really looking forward to also get back into the hobby, but yeah, need to finish stuff. Looking forward for the Christmas holiday.
All right, and one last question about the shortage of PLA to finish this out. Do you know anything about the worldwide PLA shortage? Because I sure don't.
I read this comment just like a couple of minutes before we started, but I have read the, I think, price increase that Filamentive put out a couple of days ago or something like that, where they said, okay, they currently have to adjust prices because there is a shortage of PLA, and shortage of PLA means that the prices are higher. So there might be something to it. Polyalchemy even said they're currently stopping production because either the PLA is too expensive or they're not even able to get it anymore. I don't have insight into that. Don't know. Maybe research it a little bit more, but there might be something to it.
Apparently, I mean, well, we're not on the manufacturing side that much, at least not on the filament manufacturing side. So apparently there's something going on, but we don't have any further input on that.
Yep. But links to the articles will be in the description.
Absolutely. And I think that's going to be it for this one.
Yeah. Thanks for listening. Thanks for tuning in. Thanks for your time, Tom.
Yeah, thanks for your time. And for you guys, of course, get subscribed on YouTube. Listen on Spotify, iTunes, any other podcast platform, as long as it's not Podimo. Like the video on YouTube if you want to support either of our channels. And with that, also the Meltzone Podcast. You can find our patrons linked below. We greatly appreciate, even if you're just giving $1 a month, that does make a difference. And yeah, thank you for listening. Thank you, Stefan, for your time. And we will see and hear you all in the next one.
Bye.
Bye.